Good morning, everyone. I think I have everyone.
Good morning.
How is everyone today?
I'm doing well.
Awful rainy for me today.
How you doing?
All right.
That was good.
Like I said, too much rain for me.
Yeah, I feel that.
How did test go? Everybody okay about that? Okay. Go okay for everybody? All right. Hopefully you saw the posting about the practice problems that I sent up about last Tuesday's class. There were some practice problems I put up yesterday afternoon, evening. So I wanted to spend a few minutes this morning just kind of going over the answers to those problems. I know you folks like to have the answers. You may or may not have looked at those practice problems yet, but that's the first thing that I want to go over this morning. If you haven't looked at them yet, take some time to go over them. It just kind of helps review the concepts that we went over from Tuesday's class. So please be sure you take a few minutes to look at those practice problems. So I'm going to flip over to share that information. Can you see my page here? Yes or no? Someone please answer.
Yeah, we can.
Yes, you can. Good, good, good. Okay. All right. So this first set of problems asked you to read through different cases or different scenarios, ever how you want to think of this, and look at whether the situation represent an observational study or an experimental study. And so you're just trying to decide based on the description which category it would fit under. So with that first one, a study to determine whether there is a relationship between the rate of cancer and an individual's proximity to high tension wires. That is an observational type of study. When you look at rats with cancer and divide them into two groups and apply one type of medication to one group, another type of medication to the other group, and then remeasure, that is an experimental type of study. And then it just goes through different examples where you are reading about each situation and then having to decide whether it is experimental versus observational. So that is some practice problems looking at observational versus experimental studies, looking at case situations to make that decision. The second part of those practice problems look at sampling techniques. So remember we talked about cluster sampling, stratified sampling, simple random sampling, systematic sampling. Those were different types of sampling methods that we talked about. So that should be in your notes. And then we're looking at various cases or situations and trying to decide which type of sampling is being used. So when you read this first example, we have a television organization that's sending out a questionnaire, and they send that questionnaire, and here's that key word, to selected counties of a state. When it sends it to selected counties, that is putting the information in clusters, in groups, and it's collecting the information from all of those clusters or groups. And so that makes that be cluster sampling. If it randomly picked from each of those areas or those counties, then that would change it to be stratified, but it's picking the entire cluster to get its information from, not just randomly picking selected people from those areas. So that's a difference between cluster versus stratified. A manufacturing company using a survey at the front of a grocery store to collect data for their product. That is by asking every 10th customer that goes in and out the store. That's using a systematic way of sampling. A cable company sending information to their 20,000 subscribers, and they randomly select 1,000 to send the questionnaire to. That is simple random sampling. So that just gives you an idea of reading various scenarios and trying to decide how the sampling applies to those situations. Sometimes it's pretty clear cut. Sometimes it's a little tricky to try to figure out which way it is. The third example all deals with passengers on a plane and collecting information. And we're looking at various aspects of collecting data from those passengers on that plane. And within that, we're using different sampling techniques. So from that one plane with the different methods, we're identifying what type of sampling is being done within those particular categories. So that continues over onto the back with the passengers. The fourth part looks at using the vocabulary terms population, sample, variable, or variable of interest, and the method of data collection. And so we read a particular case situation. So we have gardeners that want to treat non-chemical way to get rid of insect pest. They have traps. They apply 10 traps in the large garden, one of each kind of trap, and then they wait a time period and go back and see what the traps have collected. So the population, what are we trying to get information on? We're trying to get information on insect pest. The sample is only the insects that we collect from the traps. The variable of interest is the number of bugs that we collect. And then, of course, the method of collection for this case is simple random. It is an experimental method when we put out the traps, but it is simple random sampling. There is a second case for you to look at in using that same vocabulary information and deciding how that vocabulary fits in that situation. The fifth set of problems look at identifying qualitative versus quantitative for our variables. So as we read the temperature in Alaska, that being quantitative, the make of an automobile qualitative, whether or not a 6-volt battery is defective, that makes it be qualitative. The weight of a lead pencil is quantitative, and so on. So that gives you an idea of how to identify what type of variable is being used in your data collection. And then the last part is looking more specifically at your quantitative variables and deciding, is the variable continuous or discrete? Remember, continuous means that it's going to be measurable. Discrete means it's countable. So the length of time until the pain reliever begins to work. Length of time is measurable, so that makes it continuous. The number of colors used in a statistics textbook is countable, so that is discrete. The number of chocolate chips in a cookie is countable, so that is discrete. So all of that gives you an idea of how to apply those terms in specific situations. So that is the purpose of those practices, give you experience using that information in those particular situations. So you can see how that information is used. Any questions on those practice problems? Anything that we might need to go over a little more in depth? Anyone? All right, so that's the first thing that I wanted to spend a few minutes on, was looking at those practice problems. There are already, there is also posted a lesson 2 point in the notes and practice problems that covers frequency distributions. And so that is something that you are supposed to do on your own in terms of a lesson and the practice problems. So you want to be sure that you check that out as well. And then we have our lesson today, which we're starting. And the first part of the lesson is on measures of central tendencies. For most of you, this lesson is going to be review. There will be some components to it that may be a little bit new in terms of the formality of the statistics part, but for most of you, hopefully you'll find it rather easy in terms of things that you have done before. So measures of central tendency. This just means that we are finding measurements about things around the middle, the center, that deal with the center of the data. A lot of times we refer to this as the average. And average in this case does not mean just calculating the mean. It just means finding the center of the data. So we have to be careful in how we refer to measures of central tendency. We're going to start right off the bat with the mean. So in statistics, rather than calling it an average, we do call it a mean. I know many of you are used to calling it an average. In statistics, we use a formal formula. And for many folks, that's what makes statistics look complicated, is the formulas that are used. And so there's your first formula. That's a formula for finding the mean. Well, all of you know how to find the mean. You add all the values up and you divide by how many there are. That's how you find the mean. Well, that's what that formula is telling you. It's still telling you to do that. You just need to know what the symbols mean. So the X with the bar over it is referring to the mean of your sample population. So whenever you see X with a bar over it, it is referring to the mean of the sample. The X without the bar is referring to actual data value. Then that funny looking symbol, some of you may recognize that. That is a Greek letter called sigma, and it is a Greek capital letter. And it means to find the sum. So when you see that symbol, it's telling you to add something up. And then the little n means the number of data items. So if you know what each of those mean, the formula makes sense. The mean is found by the sum of all the data divided by the total number of data. So that's what the symbol means, and that's what the formula means. So just like we have said before, the mean is the quotient of the sum of all the data values and the total number of data. So what is the mean? The quotient of the sum of all the data and the total number of data. That's what that formula means. Now you will also see another formula that looks very similar to this one, but it has a few different symbols that looks like this. Now, one of the symbols that's different is this first symbol. Instead of the X with the bar over it, that little symbol is another Greek letter. And it's called mu. And it stands for the mean of the population. So the X with the bar over it is referring to the sample data. The mu refers to the population data. It's just being a little bit specific about what you're referring to. The capital X is referring to data from the population. It's a capital letter instead of a lowercase letter. And the capital N is the number of data values. And again, from the population versus the sample. The sigma still means the same thing. It means add them all up. So really, the only difference in the formula is really whether it's a sample mean or a population mean. That's really the big thing you need to know. Standard rule. Round one place more than the data value. Now, what does that mean? If the data is to the 10th place, we round answers to 1/100ths place. Standard rule for rounding. So you shouldn't have to question yourself. How do I know where to round to? This is just a standard rule that you use when you're rounding. Now let's look at an example problem. We have data for the number of days off in a year. For 9 people that work. So we have 30, 20, 26, 40, 36, 23, 42, 35, 24. And we want to find the mean. I'm not as concerned about whether this is population or sample, but we're going to consider this a sample set of data. In order to do it, I'm going to add up all the data values. And I'm going to divide it by how many there are. And so I get 276 divided by 9, which is 30.66 repeating. So how do I know where to round that? According to my standard rule, one place value beyond the data. Since the data is to the whole number, I round to the 10th place. So that would be 30.7 number of days off. That is the mean number of days off per year. Pretty easy. Pretty much review. You know how to find a mean. The biggest thing about this part is learning the symbols and the formula. Seeing the formula. I would suggest for you, for this particular unit, is to start yourself a formula sheet, because you're going to need the formula sheet for the test. You're going to need the formula sheet for the exam. But start a formula sheet and just place your formulas on the sheet, one sheet, and have them all in one place so you have them all together to use. That may be helpful for some of you. All right, our next one is the median. There is no symbol for the median. It is considered the middle value that balances the data. 50% of the data on each side is what the median does. The first step is to always arrange your data in order. Least to greatest. If you don't do that arrangement first, you're going to have trouble. So I'm going to go back and refer to our number of days off problem, and we're going to arrange that data in order from least to greatest. So that would be 20, 23, 24, 26, 30, 35, 36, 40, and 42. To find the middle value, we would count the number of items in and divide it by 2, and we would round up. Now, if it is an odd number when we count them, there is only one middle value. So in this case, 9 divided by 2 is 4.5, and so I round that up to 5. So the 5th item in that list is the median. 1, 2, 3, 4, 5 is the median. So this only works when it's an odd number. N divided by 2 gives us a decimal value. We round it up to the 5th item, count over to the 5th item, and that gives us the median. So what do we do? Question?
Oh, yes. Is it okay? You can let Josh in.
Sure.
He accepted. Okay.
I had let him in earlier. Now, the other situation to this is, suppose we don't have an odd number of data. Suppose it's an even number. So let's look at that situation. Suppose we have an even number of data. We're going to add an item to our list of data. Let's add 18 to our list. So we have 18, 20, 23, 24, 26, 30, 35, 36, 40, and 42. Now, instead of having 9 items, we should have 10 items in our data list. So when we do n divided by 2 this time, we're going to use that item plus one more. We're going to find the average of the 2 in the middle when we want to find the median. So in our case, 10 divided by 2 is 5. So we're going to use the 5th and 6th items. So 1, 2, 3, 4, 5, 6. That means we use the 5th and 6th items to find the median. And so we add them together. 26 plus 30 divided by 2. It's going to give us 56 divided by 2, which is 28. So now our median is 28. So that's how we would do a problem if there was an even number. So median is pretty easy. It's not a lot of calculation involved, and it does depend on whether it's an even or odd number of data items. Next, we're going to look at mode. Mode is the value that occurs often. One thing to remember with mode is that there may be more than one mode. Or there may be no mode. Some terms that we use. If there are 2 modes, we use the term bimodal. If more than 2 modes, we use the term multimodal. You could use the term trimodal for 3 modes if you wanted to. And let's look at our example. We'll continue with our data set 18, 20, 23, 24, 26, 30, 35, 36, 40, and 42. When we look at that data set, there is no item that occurs more than any of the others. So in that data set, we would say there is no mode. Another example, we might have the data set that looks like this. as we look at that data set, they do occur more than once, but they still all occur the same number of times. No one item occurs more than another item. So we would still say no mode. And a third example. As we look at the data sets, we see that 18 does occur more often than some. It occurred 3 times. If we look at the value 30, it occurred more often than some. The value 32 occurred more often than some. The question becomes, which ones occurred more often than the others? So 18 occurred 3 times and 30 occurred 3 times. Both of those are numbers more than the other data values. So the mode is bimodal, 18 and 30. So that gives you a variety of situations where you might see the mode problem come into play and how to judge how to answer the mode for those situations. The last of the central tendencies is the mid-range, and this is the one most of you probably have not seen calculated before. It is the average of the lowest and highest values. So to find the mid-range, you're simply going to take the min and add it to the max and divide by 2. So if we go back to our original example there, 18, 20, 23, 24, 26, 30, 35, 36, 40, and 42. To find the mid-range, the lowest value is 18. The highest value is 42. We add them together and divide by 2 and get 30 for the mid-range. How do you know when to use which? If you want all the data calculated, you want to use the mean. If you want a balance point for the middle, you're going to use the median. If you want a quick estimate, that would be the mid-range. If you wanted to know what value was typical, you would use the mode. So those are questions that you ask yourself in deciding, how do I know which measurement of central tendency do I typically select in order to make my calculations? One answer may be better in a different situation. If I have data that has an outlier in it, I might want to choose a median versus a mean. And we'll look at some examples where that may be true, since a mean is affected by outliers, and we'll talk about outliers a little more when we get into the next part. But an outlier is a very high or very low number, and it changes the value of the mean, where a median is the middle number regardless of that high or low number. So it's a better reflection of what the middle is. So sometimes it's better to use a median in certain situations than it is a mean. For example, a lot of times companies will say our average salary is $30,000, but they've included the executives who make a lot of money with the line workers in the factory, and the factory line workers don't make a whole lot, and the executive makes a whole lot, so it boosts the salary up to make you think you're going to earn a lot of money. So you have to consider that in terms of, is it an average or is it a median in that average salary that they're giving you in your information. So those are just things to kind of watch out for and to think about when you're talking about averages. All right, let's talk about properties and characteristics so that you'll have that information to consider when you're dealing with central tendencies. For the mean, it is a calculation that uses all the data values.
We can't see your paper.
Oh, okay. Is that better? Or you
Yes.
can't see it at all?
I can see it. You just
Okay.
had it a little up.
All right. All right, the mean uses all the data values. It varies little from the data unless it has outliers. It's used in computation and other formulas. So it's a very popular computation. It gives you a unique answer, not one of the data values. Study your lesson 2 with frequency distribution. This open-ended classes will make a little more sense if you haven't looked at that. But what that means is if you have a category that goes from 50 to forever, then that's an open-ended class. You can't use a mean in that kind of situation. But one of the most important characteristics is that it is affected by outliers. Which is an extremely high or low value. We use this term, it is not resistant to outliers. Or we use that expression, I should say, not resistant to outliers. The median gives you a midpoint, which is considered a balance point. %50 of your data is on each side of your median. It helps to divide the data into upper and lower halves. You can use a median in an open-end class. And it is typically not resistant, excuse me, I said that wrong. It is typically resistant to outliers, which means it's not affected by the outliers. For the mode, it's used when you want an evaluation of the most typical case. A mode is super easy to determine. A mode is a measure of center that can be calculated or used with qualitative data. You can't find mean and median with qualitative data, but you can find a mode with qualitative data. I didn't say this above, but this is typically not a unique value. In other words, it's not different from the data. The only time it's really different is when it is an even number of data. The mode is typically a data value unless there's no mode. And it is resistant to outliers. Again, resistant means it's not affected by outliers. And last, with the mid-range, it's an easy computation. And pretty quick to do. It gives you a middle value that is close to the median. And it is not resistant to outliers. And that is the case because your outliers are generally your smallest and highest values. So you're using your smallest and highest values there. So that is very much the case that it's going to be resistant to outliers. All right, we're going to take a break here, and when we come back, we're going to work on finding measures of central tendency with grouped data, and that's what we'll work on. So if we'll take a break for about 10 minutes, get a stretch, something to drink, and I'll see you back then, okay?